Alright guys, so we're doing methods of preparation of alkyl halides. This is where your main chapter starts from. Okay. Now first one is from alcohols. Okay. Now I'm taking ROH, which is my alkyl alcohol, right? ROH. Now R is my hydrocarbons, right? It could be anything, whatever chain I can make, right? So I'm reacting ROH with HCl in presence of anhydrous ZnCl2 and getting RCl plus H2O. Alright. Now just remember this is a racemic mixture. Racemic mixture. And it's an SN1 reaction. SN1 reaction. Alright. It's an important reaction, okay? And I'll explain to you why is it racemic mixture and SN1 reaction when we get to that topic. Alright. Now ROH with phosphorus trichloride. I get RCl plus H3PO3. Alright. Now we'll just balance this equation. If I put 3 here, I'll put 3 here. Alright. Clear? Now ROH plus PCl5. What do I get? I get RCl plus POCl3 plus HCl, right? Now in these two reactions, they usually ask you what your byproducts are, like this. What your byproducts are. Okay, so or balancing the equation. Alright. Now for the fourth one, ROH with SOCl2 in presence of pyridine. What do I get? I get RCl plus SO2 gaseous plus HCl gaseous. Do you notice one thing? The product is in its purest form. That's why this reagent is the best reagent for conversion of alkyl halides. So again, which is the best reagent for conversion of alcohols to alkyl halides? SOCl2. What is this called? Thionyl chloride. Right? It is the best reagent for conversions of alcohol to alkyl halides. Why? Because the product is in its purest form. Purest form, right? SO2 is in gaseous form, SO2 is in gaseous form, and HCl is in gaseous form. Now, what is the order of reactivity of alcohols and why? It is tertiary is to secondary is to primary. Why? Because these reactions follow carbocation mechanism. Carbocation mechanism. I'll explain your carbocation mechanism properly in SN1 reaction, okay? So now, what happens is the tertiary carbon, which is like this, it is more stable actually, it is very stable. So the product wants to move towards the tertiary carbon, right? So hence the reaction moves faster when it's at the tertiary carbon, right? So that's why you have tertiary is to secondary is to primary. Clear? What is the order of reactivity of hydrogen halides? What are hydrogen halides? HF, HCl, HBr, and HI. We know one thing, when we go down the group, the bond length increases. My bond length increases, right? Why does it increase? Because of atomic radius, because of electron shielding effects, and because of nuclear charge. All these factors together, my bond length increases, right? So therefore, HI is more reactive than HBr, is more reactive than HCl, is more reactive than HF. Why? Because its bond length is big, right? So it's easier to break. Whereas over here, the bond length is getting smaller. Bond length is getting smaller. Okay, that's why it's more reactive. Okay, for hydrogen halides. Okay, for hydrogen halides. Clear? Now, can this method be used to convert aromatic alcohols to aryl halides? Just think once. I have phenol. This is my phenol in reacting with HCl in presence of anhydrous ZnCl2. Can I get chlorobenzene? Can I get chlorobenzene? No. This reaction is not possible. This reaction is not possible. Why? Because it undergoes resonance. You guys know what resonance is, right? Resonance. Right? So, how does resonance work? Basically, you take, this is my lone pair. My lone pair becomes my bond pair. My bond pair becomes my lone pair. That's it. That's literally it. This is my lone pair. Lone pair becomes bond pair. Bond pair becomes lone pair. Clear? Move it. Move the charge. Now it becomes O plus. Right? So my lone pair became my bond pair, and my bond pair became my lone pair. Right? Now, moving the charge. Lone pair became bond pair became lone pair. Keep moving the charge. This is my bond pair, this is my lone pair, this is my bond pair. Lone pair became my bond pair became my lone pair. Clear? Right? Now this lone pair became bond pair became lone pair again. Alright? Now look at this. 3 out of the 5 resonating structures, 3 of them have double bond with OH and benzene. That's why it's showing double bond character. Double bond character. Right? Since it's showing double bond character, it is harder to break this. It is very difficult to break this bond. Therefore, it will not go through this reaction. Okay, why is it not going through this reaction? First reason. Since it's showing resonance, it has double bond character. So it is harder to break this bond. That's why it cannot undergo this reaction. We cannot use this method to prepare aryl halides. Alright? Now the second method is from hydrocarbons. What am I doing here? I'm doing direct halogenation. I'm reacting methane with chlorine in presence of UV light. Right? So what do I get? I get a mixture of products. CH3Cl, CH2Cl, CH2Cl2 plus CHCl3 plus CO plus C2H6 plus Cl2 plus HCl. So I'm getting a mixture of products, right? I'm getting a mixture of products. I'm not getting it in the purest form. I'm not getting what I want. I'm not getting this fully. I'm getting a mixture of products. Okay, so I'm not preferring this reaction. Again, free radical halogenation of alkenes is not preferred. It's not a preferred method for preparation of haloalkanes. Why? Because we get a mixture of products, right? We get a mixture of products. Okay, so it is harder to separate them. Therefore, we don't prefer this reaction. Alright, so we do not prefer this reaction from hydrocarbons. Clear? Now we're doing from alkenes. Okay, so this is propane reacting with HCl. This is going to be following Markovnikov's rule. This is my 11th grade chemistry, right? So now, remember Markovnikov's rule is rich becomes richer. Rich becomes richer. Alright, remember that as your Markovnikov's rule. This is my delta positive, this is my delta negative. Right, so my positive will go to the rich carbon already. My negative will go to my poor carbon, बेचारा है ना, बेचारा carbon poor के पास चले गए अब. That's what. So CH3, CH, Cl, CH3. Now if I want to name this carbon, how am I going to name it? What is my IUPAC name? 1, 2, 3, right? 2 chloro propane, right? Now what is its alkyl halide degree? It's 2 degree alkyl halide, no? Second degree alkyl halide, right? Because alpha carbon is your basics, first 2 videos, don't forget it, right? Clear? So remember this as rich becomes richer. Now again, this is propene with HBr. Rich becomes richer. Here and here. Clear? CH3, CHBr, CH3. Same way again, rich becomes richer. Right? Right? Now again, CH3, CH, Cl, CH3, rich becomes richer. Right? Now there's one exception over here. When I take propene with HBr in presence of peroxide, it follows anti-Markovnikov's rule. Now rich becomes poor. Okay, it follows anti-Markovnikov's rule only in this case. So what happens? My hydrogen goes here. Okay, my hydrogen goes here and my Br goes here. Clear? CH3, CH2, Cr. The reaction is very, very, very important. Very, very important for my conversions. Very important. Remember, whenever I want to complete a double bond to a alkane, okay, with a halogen, I will use this reaction. This is very important reaction, okay? Now this only happens with HBr in presence of peroxide. It does not happen with HCl in presence of peroxide. Only with HBr and peroxide, okay? And when I'm using HCl and peroxide, I'm still getting the same Markovnikov's rule. Anti-Markovnikov's rule is only followed when I'm using HBr and peroxide, okay? Remember this. Always remember, Markovnikov's rule is rich becomes richer. Alright, but when I'm using HBr in presence of peroxide, it is anti-Markovnikov's rule. This is very, very, very important, okay? It's going to be used in your conversions almost everywhere. It is very important. Okay, next one is halogen exchange. Okay, I'm using RCl or RBr. I told you in the first lecture, right, that iodine and fluorine. Fluorine is very reactive, right? Fluorine is very reactive. So we have to find different methods to get alkyl halides, right? To get alkyl fluoride, right? Or alkyl iodides, right? Because it is very less reactive. This is very highly reactive, right? Now, when I react with NaI in presence of acetone, what do I get? I get Ri plus NaCl or NaBr, right? When it's RCl, I get NaCl. When it is RBr, I get NaBr, right? This reaction is called Finkelstein reaction. It's a name reaction. Finkelstein, mark this reaction, very important. These name reactions are very, very important. These reactions are very, 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 very important. Okay. Now next one is when I'm reacting RCl and or RBr with AgF, I get RF plus AgCl or AgBr. Okay, this reaction is called Schwarz reaction. Schwarz reaction. Mark this reaction also very, very important. Both of them are very important. Now practice all these equations properly, okay, because they're very important for your conversion. Okay, see, this is the only organic chapter that you find a little hard to do. Once you do this chapter properly, no, all your organic chapters will be easy. Okay, so do this chapter properly, do these questions and equations, everything properly. Okay, understand it. Okay, thank you for watching this video.